In this experiment, we used pH meters to detect the differences between strong and weak acids and bases. A strong acid completely ionizes in water, meaning it will break down into both hydronium ions and its respective anion. You can see this with the hydrochloric acid in its equilibrium equation. The equation is able to reach equilibrium when the rate of the forward and reverse reactions are equal. A weak acid only partially ionizes in water. As you can see with the acetic acid equilibrium equation, acetic acid breaks down into hydronium ions and its respective anion, but because it only partially dissociated, the anion concentration is significantly higher than the concentration of the hydronium. The equilibrium process can be manipulated through the use of buffers, which we will talk about later. At the beginning of the experiment, the pH meter must be calibrated. To do so, the probe must be taken out of its storage container and rinsed with distilled water. On the meter, you can find the Calibrate tab under the Sensors tab on the main menu. Now the probe can be placed carefully in a buffer solution of a known pH while you enter the numerical value of the pH on the meter. Press Keep and begin the process again with the second buffer solution, starting with rinsing the probe with distilled water. Once you have completed this 2-point calibration process, you should place the probe back in a buffer solution to ensure it is reading correctly. After you are sure it is working properly, place the probe back in its storage container. The first part of the experiment required testing 2 solutions for their pH. Since the pH meter has been calibrated, we simply placed the probe in the apple juice and read a pH of 3.18. The orange juice had a pH of 3.68. Each value was then recorded in our lab notebooks. The next step of the experiment was to obtain the pH of a buffer solution. As you can see, the probe was washed before and after use and properly stored once finished. A buffer is a solution that can resist changes in pH when a limited amount of acid or bases is added. It can resist changes because the buffer contains both a weak acid that can react with an added base and a weak base that can react with an added acid. For example, the buffer we used in this experiment contained 30 milliliters of 0.2 molar sodium hydroxide and 60 milliliters of 0.2 molar acetic acid and had a measured pH of 4.22.